Let's implement a buffer that doesn't throw away information like the circular buffer does. So a buffer of t. And I'll keep this class inside of the same file as the rest of our code, so it's easy to keep everything on the same screen. This is buffer of t. It also needs to implement iBuffer of t because these two buffers need to be interchangeable. We can pass either one to the rest of the application. And once I have the interface here, I can use Visual Studio and hit Control period, drop down this menu, and ask it to please implement the interface iBuffer of t. Of course, it doesn't know what the implementation inside should be, but at least it gives me the members to fill out. And now creating this buffer is going to be amazingly easy now that we've had the module on the collections that are in system.collections.generic. Because the behavior that we saw from the circular buffer, the way we want it to act is we really want a first in, first out data structure. And as we've seen, there is a first in, first out data structure that's already in the .NET framework, and that is Q of t. So I'm just going to create a field and new up a Q of t, but I'll run into one problem here, something you have to be careful about. There's two Qs in the .NET framework. There's one in the system.collections namespace, and the Q that is in that namespace is not generic. All of the collections that take generic types are in the system.collections.generic namespace. So once I fix up that namespace, we're good to go. Visual Studio is happy. The C# compiler will be happy. So how do I know when the queue is empty? Well, I could just return queue.count equals 0. If the count is 0, the queue is empty. So I just need to return that expression. Then when I need to write something, I can just place it into the queue. And when I need to read something and return it, I can just ask for dequeue, which does exactly what I want. It takes the first item that is in the queue, it pulls it out of the queue, and then it gives me back a reference to that object so I can hand it back. And that is everything I need for a buffer of t. You might say, well, why don't you just use a queue? Well, it might be a case that I want to provide a slightly different API for the code that is using a buffer. I don't want it to use a queue directly. And in this case, I want to certainly provide some additional features beyond and above what a queue provides when I implement things like a circular buffer. So I don't necessarily want the program over here to use a queue directly. It's going to use buffer, which basically now is wrapping a queue. But it does implement iBuffer of double, so I can create a new buffer of double. I can pass it around to everything that needs it. And if we want to make sure this works, I could just run the program real quick, make sure it is still accepting data, make sure it is still summing data, and it comes out with a 14.8, which looks correct. So these generic interfaces can be very powerful. They can allow us to build abstractions and decouple clients from a specific implementation, but still be type safe. And there's many examples of some great generic interfaces throughout the .NET framework. We're going to look at a few in this module. But before we do, I want to revisit the relationship between buffer and circular buffer for a moment. Now that we've seen how easy it is to implement a buffer just using a queue, which is part of the .NET framework and is tested and works well, should I also be using a queue inside of circular buffer? And I think the answer is yes, but maybe with a little bit of a twist. So let's look at that next.